Here is another video regarding sketching the graph of this polar equation yr equals to 8 sine 2 theta. This is a table value that I prepare. I go 15 degrees at a time in my table value. My increment is 15 degrees, 0, 15, 30, 40, 45, 60, 75, 90, 105, 15 degrees at a time. And then in radian, I go from pi over 12, and then 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, so on and so forth. So I would like to go 15 degrees at a time or pi over 12 at a time because my graphing paper is 15 degrees at a time. And then to get this table value, the most fundamental method is you set your calculator in degree mode, and then you can start plugging in theta in degree, all right, in degree. So 2 times 0 degree, 2 times 15 degree, 2 times 30 degree, and then you round your answer to fill up this table. And then we will plot the points and then connect them. Is there a way to get this value much faster? Yes, you can use your TI-84 graphing calculator. Here is how. Let me move to the next page. So you need to go to set your calculator in degree mode. To do so, you hit the mode key, and then I need you to set your calculator in degree, and then you are graphing polar equation. Degree and graphing polar equation. And then for the degree, for the window, before we need to set up a window. So we go to the window, and then we are in degree, right? I want you to go from 0 to 2 pi, which is 0 to 360 degree. And then your theta step, this one I highly recommend you to use a 0.2 or 0.1 because you want to go 0.2 degree at a time. That smaller value enables the calculator to trace the graph at a much slower speed. Trust me, that is a great thing to do. Tracing in a very slow speed. And then the X and the Y, I will just do just like in your XY plane. I will go negative 10 to 10, one step at a time. And then if that is not big enough to see the graph, or if that is too big, and I will come back to the window to do some tune-up to see the graph. Once you're ready, you go to the Y equal, you input your polar equation. Y equals to 8 sine 2 theta. Oh, by the way, I need to remind you, can you check your plot 1, plot 2, and plot 3 and make sure they are not selected? At this time, they are not selected. If any one of them is highlighted like that, that means that is selected. So or you cannot graph that and this polar equation at the same time. So why don't you use your up, down, left, right arrow, move the cursor to plot 1, and then click enter to deselect that. So they will be not selected. So if you don't see anything, just like my screen, that means none of them is selected, then you are all good. If that is selected, you might see an error. Okay, 8 sine 2 theta, I use the second one, not the first one, because I want to see a red graph. And then once you're ready, click the graph key, and then they will trace the graph very slowly. Okay, this is what the graph is supposed to look like. Some people, they would just call this like a rose graph, a rose curve or something, because that looks like a rose flower. So you have 4 petals, something like that. And then what about the table? So for the table, let's do some table setup. So can you go to second and then window? Do you see that above the window key there is a table set? That is for table setup. You click second, you click the window key. And then I want to start from 0 degree. My increment is 15 degree. Again, we are in degree mode. 0 degree to 15 degree. And then once you're ready, you click second graph. Above the graph key, there is a word table in blue. That's why you click the blue second key, and then you click the graph. And then you see all this table value. Click the down button to see more. And then you copy that over to your graphing paper, or to your paper. What about Desmos? For Desmos, you need to hit this wrench, and then you select that for polar graph. Otherwise, the first one by default, that is for rectangular graph, which is the XY plane. And then once you did that, you can go to the right-hand side, just input R equals to 8 times sine 2 theta. Theta goes from 0 to 2 pi. If you want to make the graph change colors, you click the gear icon. You can change the color. You can change the boldness to 3 or 4 to make the line really bold. And then there is a one really good function, is like a hidden feature on your in Desmos. I highly recommend you to try that. Just do you see that there is a 2 pi? You can change it. You can change this to what? To 1 pi over 12, because my graph starts from 0 and then 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12. So what I want you to do is you start from 0 to 1 pi over 12, and then you can see that the calculator, they actually graph the piece from 0 to 1 pi over 12. And then you add it, change the 1 to a 2, and then you will see the next piece. Change the 2 to a 3, to a 4, to a 5, to a 6, and then you can see this one piece at a time. Trust me, I strongly recommend you to try this. Just change the number from 1 to 2 to 3 to 4 to 5 until you reach to 2 pi, which is 24 pi over 12. Try it. It is so helpful when you do this using Desmos. Try it. I strongly recommend you to try it. All right. Okay, I am going to go back to my table, and then these are my table value. I will do this like one color at a time, because one color really represents for one petal. You can take a screenshot right now, because once I move down, you can't see the table anymore. Did you get it? Screenshot? Or use your phone to take a picture of that. Okay, the first point is at 0, 0. That is, I need to write the numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8. -1, 5, 6, 7, 8. Okay, the first point is 0, 0. That is right at the origin or the pole. And then the next point is 4, 15. So 4, 15 degree. And then 6.93, 30 degree. And then we will reach to 45 degree is at 8. And then symmetrical, 6.93. And then back to a 4. And then back to a 0. So we will follow this path. And then we are back at 0. That's why I mark my table at 90 degrees 0. And then I change color to 105 and a -4. So -4, 105 degree. 105 is one quadrant plus one step. You are at -4, then you go one quadrant plus another step. One quadrant plus another step. So that is right here, -4. So we will do the same number one more time, but in negative. And then -6.98, -8, -6.98, and then -4, and then back to a 0. So we will go this way. The petal is symmetrical. All right, then we are back to 0. That's why I mark the 180 degrees 0. I use blue to mark it. That means from the table, I went to the graph, and then I marked the table, so I know that I am start right there. And then now let's do the purple. 195, 4. Where's 195? 195 is here. So you have to go a full half circle plus another step. And then we are having 4, right? Okay, 4. So we go a full circle plus another step. Then that is where we start, right here. Okay, 6.93, 6.93, and then 8, 6.93, and then a 4, and then a 0. So we will go this way. Okay, back to the 0. That's why I mark my 0. And then the last piece is in green. I see a -285. 285 is right there. So we will go a one full circle plus another step. But that is at -4. So we go to -4. We go to -4 and then 285. So 285, that is 3 quadrants. 1, 2, 3. And then plus another step. So we are right here. This is -4. 0, 1, 2, 3, 4. Yep. and then 6.9 degree, and then an 8, 6.9 degree, back to a 4, and then back to a 0. I don't have a 0 because this one will be a 0. We just return to the 2 pi. The 2 pi is the same thing as 0 degree. Okay, then we go this way. There we go. That is the graph. So I color coded everything. So that should be pretty easy to read, and even you can even take a screenshot of that. Okay, then that is the end of this problem. It isn't that hard to do. Just take a little bit of practice to get used to the plotting the points. With a little bit practice, I am sure you can do it smooth and you can do it fast. Okay, that is the end of this video. I will meet you all in the next lesson. See you there.